Assalamualaikum warahmatullahi wabarakatuh. So we continue with another example. I think this is the final example I will give on the topic of rotation about fixed axis. So we have this kind of system. The 20 kilogram cylinder rod is rotating in vertical plane and at the instant has an angular velocity of 5 radian per second. Determine the rod angular acceleration and horizontal and vertical component of a reaction at the pin at this instant. Okay, so first of all, you have to know, or you have to determine the location of G, because G, when you know G, you know where the point of accelerated, you know the accelerated point. If you don't know the G, so you are in trouble. So where is G for this cylinder rod? And doesn't matter where it is pinned. Doesn't matter where it is pinned. Basically, for this cylinder rod, G in the middle. This is a G in the middle. You have to know that one. So while it's rotate, you know that it will experience what? AT and AN. So so that's what you have to know lah. Basically, in this problem, we have to draw two things: FBD and kinetic diagram. So FBD, anything about force and moment. Sorry. Sorry, we got weight, we got moment, 60 Newton meters, and then you have a reaction. Don't worry about where the direction of this reaction, upward or downwards. It will tell you the exact answers after you solve everything. So you can put here is O Y for the example, and then O X. Why I put O X and Y? Because normally what we write for the coordinate system is X Y. Or if you know this the direction of rotation, and you know AN and AT, you can simply say that instead of using X and Y, I want to choose the coordinate system T and N, because of when I draw the kinetic diagram, I have alpha, yes, and I have what? I have AT, and I have AN. See that AN to the left, and you can choose AN coordinate system to the left, T downwards. It's similar. It won't give any problem to you lah. As long as you understand the relationship between X and Y that we are normally use, and N and T component. Okay, let's solve this one lah. Let's solve this one. So if I draw it, so I choose these components. I choose this coordinate system lah, X and Y. X and Y. So the summation of force in X to the right is positive, is equal to MAGX. So in X we have OX only, correct? OX only. There's no other force. In X only OX. X is equal to what? MAGX. AGX. AGX is what? If you see that in X you have only AN. AN. So AN is to the left. So it will give you a negative lah. Negative. AN to the left in X. equal to an. Instead of agx, we put an. The negative because of it goes to the left. Agn. What's the equation for agn? It is equal to m r omega square. mr omega square. mr omega square. So it is equal to, what is m? M is 20 kilogram. The radius, radius of course from G to O, G to O, because an is r G, O to G, omega, r square omega, r square omega. So r is what? 3 divided by 2 is 1.5 meters, 1.5 meters. 1.5 meters times omega. So you have one equation here because you have omega and ox as the unknown. Okay. Right? Yeah. And don't forget, I got that. No, I don't know the mistake, but I forget that omega is given. Omega is given. So when omega is given, you can solve this one directly. Sorry for my omega is given as 5 radian per second. So basically, your OX. OX is what? OX is, the answer for OX is 700, negative 700 Newton. So negative means that the it opposite direction basically. Basically your OX, the direction of OX is to the left. Doesn't matter. Yeah, doesn't matter since OX is negative because you put X is to the right. You just left your answer as it is because it's correct. Because you show OX to the right. And then of course you got negative. If you put OX to the left, and then you will get negative. That's not the issues. And then summation of F in Y. Upward is positive. So MAGY. So MAGY is also equal to wait no, before that summation of force in Y, we have what? Positive OY, negative weight. That's the only force in Y. So Y is positive since it goes upward, minus omega W, which is 20 times 9.81. Okay, and this one equal to what? MAGT, tangential component. And this one goes down. You see, it goes down. It goes down. So it will give you negative lah. Because upward is positive, downward is negative. So here you will have negative 20 R alpha. R is 1.5 meters. So you will have here OY minus OY minus 196.2 equal to, so R is 1.5 meters. So here is minus 30 alpha, right? So you have two unknown here, which is OY and alpha. So you cannot solve it lah. So you need another equation lah. You need another equation. So summation of moment, at G, at G, or at O. It's up to you. It's up to you. If you choose, okay, we choose summation of moment at O. At O, counterclockwise is positive. eh? So equal to summation of moment due to kinetic at O. Alright. So now you are calculating the mass moment. I mean the moment at point O. Not point G. Point O. So how to do that? How to do that? We have at point O. At point O. We have Wn external moment only. And we have external moment is clockwise. So it will give you a negative values, 60 Newton meters. And how about weight? Weight also create clockwise. Create clockwise. So it will give you a negative. Right? Minus the distance is 1.5 times weight. Weight is 20 times 9.81. And then the summation of moment due to kinetics at point O, you have what? You have Ig alpha. That you cannot run away from Ig alpha, but you must plus with the mass moment of, the moment due to the kinetic. Kinetic, how about it's about the acceleration. Because you have the I alpha, you have Ig alpha, it's there, and then you have to consider these two things, 1 and 2. Okay, for An is not counted because the direction of An cross cross O, so it's not counted. The only component that counted is At. At must be on the right hand side lah. The summation of moment for FBD must be on the left hand side. For the right hand side, it's come from all the component in kinetic diagram. This one from if I change if I change the colors. So this one, if you refer all these things come from the FBD. Either it's counted or not, it's another story lah. But it's come from the FBD. This come from the kinetic diagram. Okay, don't forget about that lah. So if you are looking on this equation, this come from the 60, and weight. So OX and OY is not counted since it crossed the point O. Since it's crossed the point O, so it's not counted to calculate the moment lah. For on the right hand side, you have Ig alpha, and then you have An and At. At is not counted. Sorry, An is not counted since the direction of An, you see, cross the point O. It's not counted lah. It doesn't create a moment, but At create a moment. See that? It will create a moment, but in clockwise direction, right? So here is It. So clockwise is basically clockwise is a negative lah, negative M negative R times M A G T. Right? So negative because it's down. It's a clockwise lah. It's clockwise. Similar to this one, Ig alpha. You see that? Ig alpha is also clockwise. It's rotate clockwise. It gives you a negative value here. Don't forget. So if you can calculate here, it will give you right here is negative 354.3 equal to what is the mass moment of inertia at G for cylinder rod. If you refer to the table of mass moment of inertia, it give you 1/12 ml square. Right? This one is R. R is what? 0.15. Sorry. 1.5, 1.5, 1.5. Mass is 20. AGT is R. AGT is R alpha. R is 1.5 and alpha is alpha lah. So here, what is the unknown here? And 354.3. If you put everything here, the answers here, uh, because M is known, L is also known, so you can calculate this one. Let me calculate first. So here is negative 5. So I got alpha here, don't forget. 15 alpha, and here is uh, 45 alpha. So here basically you can get the value directly alpha lah. Alpha is equal to 5.9 radian per second square. Okay, so means that you got directly from the summation of moment you can get directly alpha. Solve it. Since you got alpha, you can go back to the previous equation. You can replace alpha here and then you can get OY. Y is equal to what? Negative 30 times 5.9 plus 196.2. 196.2, and then you can get the answer is OY is given as 19 point 19.05 Newton positive lah. So it goes upward lah, or y basically. So you solve it lah, you solve it. And then in the textbook sometimes you can instead of calculating the moment at O, you can use the summation of moment at G itself. Try to do it by yourself, and then if you have any problems you can ask me lah. Basically what's the that's the final example in this subtopic. I hope that you can digest this one. If you have any problem, just let me know. All right, so we have another subtopic in this general force and acceleration, which is general plane motion, combination of rotational motion and translation. All right, thank you very much for your attention. If you have any problem, as I said, just let me know. Thank you very much.